What are the measures of central tendency?
Mean, median, mode.
Mean, median, mode. Very good. So we already know that if we have a data set, let's say this is our data set, and we want to describe it, if we want to measure if we want to describe the central tendency, we can report the mode of our data, we can report the median of our data, and we can report the mean of our data. Some of the deviations from the mean is always zero, and that makes it special. So we discussed all of that. And we have many different measures of measuring variation or dispersion around the mean. If we want to measure dispersion around the mean, what was the best measure of dispersion around the mean? We had range, we had mean absolute deviation, we have mean squared deviation, we have standard deviation.
The best one was a standard deviation.
Yeah, very
Standard.
good. So this is a measure of central tendency. Let me write it here. These are central tendency. Basically, they summarize and give us an idea of the numbers that we have as a measure of central tendency, and as a measure of dispersion around that measure of central tendency. For mean, we realize that standard deviation is a very successful and good measure of dispersion. Now, the next thing that we want to learn is that what would be a measure of dispersion, or how can we describe the dispersion or variation of our data if we are reporting median. But before that, tell me, why would we like to report median instead of the mean?
I think it's because of the ugliness of the mean that we might have an outlier in the system, and then so mean is not that accurate.
So what is the beauty of median then?
Median is actually in the middle. It
And
it technically
it is not affected by
it's not sensitive to the outliers.
to the outliers. Very good. So a lot of times, especially when there is a skewness in the data, we report the median as the measure of central tendency. Then the question is, how would we describe in descriptive statistics the dispersion around the median? So this is the topic. The answer to this is a way that we can describe the dispersion around the median, a method that summarizes a lot of things, that gives us a lot of description of our data, is box plot. That's why the topic of today's class is box. So let's think about a situation when we have a bunch of numbers. We are receiving a bunch of data, and this data is provided to us. As we go forward, we want to find their measure of central tendency and also describe the variation or dispersion around that central tendency. The numbers that are provided to you in real life, they are not usually sorted. So one of the things that we can do, we can use the stem and leaf technique to both sort them and have an idea of what this data is. So please take note. I'm going to introduce some data, and while I'm introducing the data, I'm also going to sort them, because if I want to find the central median, the numbers must be sorted. So now that I want to sort them, how about I also create a stem and leaf table so I know what is going on, where is the maximum frequency, and so forth. Okay. As I read the numbers, I will present them in my stem and leaf table. The first number is 28. Okay. I know that there may be some numbers in the range of single digit numbers. Therefore, I write 28 like this. So I leave some space on my sheet, and you do the same thing. Next number is 39. So this one is the next class. So I write it 39. And the next number is 23. So this is easy. I add just a 3 here. So far, we can see the numbers are 23, 28, and 39. And as we write them, they are automatically sorted. Next number is 67, as it is given to me. So I leave some space for class of 4, class of 5. I write 67 here. Notice that I'm leaving some space to do my work faster. The next number is 37. Good. The next number is 28. I add one more 8 here. The next number is 56. I write 5 and 6. Notice that I'm still leaving, just in case a number in the range of 40 will show up, and it showed up. 40 is the next number. And the next number after 40 is 28. The next number is 50. So see, by leaving these spaces, I don't have to erase and shift the numbers. And the numbers are sorted. Then 51. The next number is 45. The next number is 44. The next number is 65. 61. 27. 24. Oh, here I need some shifting, so I erase this 3. I shift it to the left, and I add my 4 here, because my numbers must be sorted. Then I have another 61, and I have 34, another 44, and that's my last number. So let's shift this 5 a little bit. 4, 5. Okay? So now we are looking at all of the numbers. We sorted all of our numbers, but I can ask you this question. Which class of the numbers have the most observations? What is the mode of this classification? That class, the first class, is the mode. The most observations are in that range. So not only we sorted our numbers, but also we got a sense of the concentration of data. Now to
Excuse me,
find,
sir.
yes,
So this class is gonna be 20 to under
30.
29,
No,
30,
to under
30.
20, to under 30.
Okay.
So yeah, 29 is still in this class. Anything less than 30 is in the first class. And this is how the stem and leaf works. It has an automatic interval of 10. Okay, so now to find the median, we need to write our numbers from the smallest to the biggest, and then we have to use the formula for the location of the median and find it. Okay, so let's write down our numbers. Now that they are sorted, we write them as 23, 24, 27, 28, 28, 28, 34, 37, 39, 40, 44, 44, 45, 50, 51, 56, 61, 61, 65, and 67. Now we have all of our numbers. The first thing that we want to do is to identify the central tendency, but we want to present the central tendency that is median. Okay? To find the median, we have to use the formula that gives us the location of the median. The location of the median, or the location of 50th percentile over 50% of observations are less than it and 50% of more observations are more than it is determined by n plus 1 multiplied by
Molecule.
percentile over 100. Now, how many numbers we have?
Many.
20.
20.
Okay, so we have 20 numbers plus 1 multiplied by 50 because we want 50% to be less than it. So that P is the percentage that we want to be less than that location. And now please help me.
10.5.
10.5.
10 point. Very good. So our median is between 10th observation and the 11th observation. Okay, so now let's find the 10th observation. This is the first observation, second, third, fourth, fifth, sixth, seventh, eighth, nine. This is my 10th observation. But the 10th observation itself is not the median. We have to go halfway between 10th and 11th observation. Okay? So just follow me how we use this location. The location is the 10th. 10th observation is 40. Now I have to go half of the distance between 10th and 11th because it's 10.5. How much is the distance between 10th and 11th observation?
4.
4.
4. Very good. And that says that our actual median, notice that the location of the median we find first, then the median itself. The median is
42.
42. Very good. So we found the median. And once we found the median, we have the central tendency. The next step is to describe the dispersion around that central tendency. And to find the dispersion around the median, notice that we cannot use the standard deviation because standard deviation, as you remember, I write it in a different color. Standard deviation was calculated by finding sum of squared deviations, and these deviations are in fact deviation from the mean. So to find the deviation, we would subtract x minus
X bar.
x bar, and then we would square it. So this is when we say deviation, we mean deviation from the mean, not the deviation from the median. And then we would divide it by, if it is a sample, we would divide it by n minus 1 to push it up. And because it is exaggerated, we would get the square root. And this would give us the standard deviation. But this wouldn't be a measure of dispersion around a median. It is a measure of dispersion around the mean. It looks at the deviations from the mean. And this is not good. So we need another some other ways to explain what are the dispersion around the median. For that, this is what we will do. We know that the range is a measure of dispersion. So we know that the range of our data, look at your own numbers because now I have scrolled, but you can look at your numbers and you can tell me that the range of our numbers is from, what was the smallest number?
23.
23.
23. From 23 to, what is the biggest number?
67.
7. And the range is from 23 to 67. The range is 44. So now we have a better understanding. The central tendency so far, we know that this is the median. 42 is the central tendency, and we know that the range is from 23 to 67. We can start presenting our dispersion and the central tendency visually right now. So this is what we do. We use an x-axis, and on the x-axis we identify the smallest number, which is 23, the biggest number, which is 67, and we identify those as two major points, the beginning and at the end of the range of our data. And then we know that the central tendency is 42. So we identify, in the exam you need a ruler. We identify wherever the 42 is, and then we draw a line, and that line is the representation of our central tendency or median. And even right now you have a visual understanding of what's going on. Half of our observations are less than 42, half of them are more than 42, and we know that the range of the data is from 23 to 67. But we do more. We will explain more. The next thing that we do, we identify the location of quartile 1, which is the synonym of saying the location of the 25th percentile, or where the first 25% of our observations are located. And for that, we calculate again n plus 1, which is 20 plus 1 multiplied, but this time the p is 25. We want 25% of observations to be less than our point. So please do the math and tell me where is the location of the first quartile or the first 25%?
5.25.
Very good. Thank you. So this is 5.25. Now, similar to what we did before, we need to identify the fifth observation, because it says observation 5.25 is giving us where 25% of observations are less than it. And here we see that the fifth observation is 28. So we write 28. Then we have to go between observation, fifth observation and sixth observation, we have to go 25% of that distance. Whatever is that distance, we have to multiply it by 0.25. Now, what is the fifth observation?
28.
Six when you're again.
Yeah, fifth observation is 28, sixth observation is 28, and this distance is actually 0. So the quartile 1, not the location of it, quartile 1 itself, the number that 25% of observations are less than it, is 28. And now we identify that. So we go to our chart and we find 28. 28 must be somewhere like this: 23, 24, 25, 26, 27, 28, somewhere like this. And that is, let me write it down. This is 28, or quartile 1, quartile 1. So we know that the data, the smallest number of data that we have is 23, and 25% of observations are between 23 and 28, which is quite.
Excuse me, Professor.
Yes.
Why did we use 0, whereas 28 plus 0 times 0.25?
Oh, why did we say 0? Because this is, we have to go, we are not interested in observation 5. Do you agree with me?
Yeah.
We are interested in observation 5.25. 5.25 is between fifth observation and sixth observation.
And they're both 28.
Exactly. So the
Okay.
distance, this distance is 0.
Yeah. Okay.
Therefore, if the fifth observation is 28, the sixth observation is also 28, then 5.25th observation is also 28.
Yeah.
Okay. Now,
Thank
the
you.
next thing that we do is we find the location of quartile 3. Okay? Quartile 3 is where 75% of observations are below that. or location of 75 percentile, and that would be 20 plus 1, 75 divided by 100. Help me. 15.75.
75.
Very good. So now we have to find the 15th observation, but we are not really interested in 15th observation. We are interested in something between 15th and 16th observation. So let's find it. So this is the 11th, this is the 12th, 13, 14, 15, 16. So the 15th observation is 51. Then I have to go 75% of the distance between 15th observation and 16th observation. How much is the distance between 15 and 16th observation?
5.
5. Very good. So now tell me what would be, this is called the quartile, the actual number of quartile 3 is, use your calculator.
54.75.
54.75. So 75% of observations are less than 54.75. Let's identify that on the chart. So 54.75 is something like this. So this is where 54, and then we identify that on the chart. And now we connect these three major points. Quartile 1, notice that median is quartile 2, 50%. Quartile 3, we identify quartile 1, quartile 2, quartile 3, quartile 2 or median, and quartile 3. And then we connect the minimum to the beginning of the box and maximum to the end of the box. And now we have the box plot. But you should ask me, okay, so what? What is the importance of this? Okay, so, and let's assume that the only thing that we have, I'm going to zoom on this, the only thing that is presented to us as the description of our data is this. And you should be able to answer my questions. What is the central tendency?
42.
42.
Very good. What is the number that 25% of observations are less than it?
28.
28.
28.
What is the number that 75% of observations are less than it?
54.75.
Very good. Now, some other conclusions. What is the range of the highest 25% numbers? The highest 25%.
54.75 to 67.
Exactly. And the most important thing, you know that economists are very interested in this question. Where are the middle class? The middle 50% of people. Okay, let's think about it. The middle 50% of people. These are the 25% that are less than the median. Okay? And these are the 25% between the median and the third quartile. So this range, here we have 25%, and here we have another 25%. So this box, the place that I hashed, shows the 50% middle class. Okay? So we have the central tendency, 42. We know where the middle class are located, between 28 and 54. Okay? And we know for example, if it was income, it would be, we know the range of the richest 25%, we know the range of poorest 25%, and this gives us a lot of information about the situation, both the central tendency and how they are dispersed. Now, let me give you an example of how this can be used by economists. Let's say this is the observation in a country in 1960. Now, the same chart is drawn for the same country now. And this is what has happened. When we draw the box is like this. Now tell me, what do you understand? Notice that I'm not giving you any explanation other than this description of median, quartile 1, quartile 3, and so forth. What has happened in this society from 1960 to, stay there, it doesn't stay, yeah, to 2025? That is 1960, the second one is 2025. What has happened?
Well, the 2025, it's shifted left.
Okay, why do you say it is, what do you mean by it shifted left?
The box chart.
Yeah, but the box has a specific meaning. So what has happened to the median income of people?
It's
Gone
decreased.
down.
Decreased.
Yes. So before, half of the people were getting 42, or less than 42, but now half of the people are getting less than 29,
8. No.
right, or 30, right? So before, half of people were less than 42, but now half of the people are getting less than 30. So definitely, this is, people have gotten poorer.
Yeah.
What else? What happened to the middle class?
There was still a shift for the middle class as well.
So
They
what has
got
happened?
poorer.
Yeah,
They got poorer.
so to be precise, to read the numbers from this data, before, the middle class of the society had an income between 28 and 54, but now the 50% middle class of the society have something like between 25 and 35.
Mhm.
Okay?
And there is
What?
still something else.
Yes, what else?
The outlier is still the same. So we can see the maximum used to be, like, let's say 67 before, if you conclude the box chart, and still in the 2025, that numbers is still the same.
So to richest people, nothing happened.
Yes,
You
exactly.
see?
Outlier
I
is the
want
same.
you to see why economists like this chart. Okay? It shows that to the richest people, nothing has happened. The poorest people, this 25%, are now having the less amount of income, and the middle class also has less amount of income, but to the richest people, they are still the outliers. And the other thing that we observe here is that the first curve in 1960s is more symmetrical, like median is relatively at the center, and the middle class are also dispersed around the center of the range and so forth. But in 2025, in that society, now we have outliers on the right side, and we have a skewed distribution.